first type of product, or I guess the second type of product, is what we call an inner product or a dot product. So if I take the vectors A and dot it with the vector B, take a look at what exactly does that mean. So this is a dot product. So we'll first think about what is the geometric interpretation of that. So if I have my two vectors here, I have a vector A, and then another vector B connected at their tail here, and they have an angle between them, call it theta. If I project B onto the same direction as A here, so this is a 90-degree angle. Now I've projected it onto the same direction as A. So I'm going to have this distance here is the magnitude of A. And then this distance right here is the magnitude of B times the cosine of the angle between them, so cos theta. So the dot product just starts from that simple basic geometric definition. It's the product of the magnitudes both projected onto the same direction. So one way of defining the dot product is by saying it's the magnitude of A multiplied by the magnitude of B cos theta. Starting from that definition, we can look at, okay, so we have these two vectors, A and B, expressed in their components here, AX, AY, AZ, BX, BY, BZ, and those are a sum of components in the X, Y, and Z directions. So how do we understand that multiplication? We want to multiply these two sets of brackets together, and we'll do that in the standard way that you would do multiplication. Say these were scalars, but we have to understand what is going to be actually the dot product of these unit vectors starting from this definition over here. So we know that for each of the unit vectors, the angle between them is 90 degrees. And the cosine of 90 degrees, or pi over 2, is just 0. So from that we can say that I dot j is equal to, need a bit more space, I dot j is equal to j dot k is equal to k dot I. Each of those are equal to 0. This is sort of a aside here. We also know the angle of any vector with itself is 0. And cosine of 0 is just 1. So I dot I is equal to j dot j is equal to k dot k is equal to 1. So from those basic definitions, so in the first on top is when theta is equal to pi over 2, and in the second set of cases, theta is equal to 0. So taking that information and putting it together with this multiplication here, we can write out in terms of just the components. If we already know the components of the vectors, we can calculate the dot product as follows. It's going to be AX times BX plus AY times BY plus AZ times BZ. So the result of the dot product between two vectors is just a scalar. So ax bx plus ay by plus az bz.